Area 51. The 1992 Underground Structure Expansion Project. In the early 1990s, as the Cold War drew to a close, the United States found itself at a crossroads. The geopolitical landscape was shifting, and with it, the nature of military and intelligence operations. The focus of national security began to evolve, placing a greater emphasis on technological superiority, clandestine research, and the development of advanced defense systems. At the heart of these efforts was Groom Lake, better known to the public as Area 51, a facility steeped in secrecy and intrigue. Area 51 had long been the epicenter of America's most classified projects, ranging from the development of the U-2 spy plane in the 1950s to the testing of stealth technology in the 1980s. By 1992, however, the demands on the facility had outgrown its existing infrastructure. The underground structures, which had been expanded incrementally over the years, were no longer sufficient to support the growing scope of the operations being conducted there. This realization led to the inception of one of the most ambitious construction projects ever undertaken by the U.S. government. The decision to expand the underground facilities at Area 51 was driven by a combination of factors. First and foremost was the need for additional space to accommodate new research and development programs. These programs, many of which remain classified to this day, required secure, state-of-the-art laboratories, storage areas, and command centers that could operate independently from the surface installations. Additionally, the expansion would provide increased security against potential threats, both physical and electronic, by burying critical operations even deeper beneath the desert floor. The vision for the expansion was nothing short of revolutionary. It called for the creation of 4 new subterranean levels, each designed with a specific purpose in mind. Level B1: Secure Storage and Logistics Support. This level would serve as the backbone of the expanded facility, providing secure storage for sensitive materials and logistical support for the various operations conducted within the complex. The design required vast, climate-controlled spaces, equipped with advanced monitoring systems to ensure the safety and integrity of stored items. Level B2: Advanced Research Laboratories. The heart of the expansion, Level B2, was to house cutting-edge laboratories equipped with the latest in scientific instrumentation. These labs would be used for a wide range of research activities, including the development of new materials, technologies, and defense systems. To ensure the integrity of the research, the laboratories needed to be isolated from external environmental factors, with custom-designed HVAC and filtration systems. Level B3: Containment and Testing Areas. This level would be dedicated to the containment and testing of experimental technologies and materials. The spaces here required reinforced structures capable of withstanding the rigorous demands of advanced testing protocols. Additionally, Level B3 needed to be equipped with specialized environmental controls to manage any hazardous materials or unexpected outcomes during testing. Level B4: Command and Control Center. The deepest and most secure level of the expansion, Level B4, was designed to be the command and control hub of the entire facility. This level would feature advanced communication systems, secure data storage, and monitoring capabilities, all housed within a highly fortified environment. The command center was to be the nerve center of Area 51's operations, capable of functioning autonomously in the event of an emergency. Given the complexity and secrecy of the project, the U.S. government turned to a company with a proven track record in deep earth construction and infrastructure development, and that had previously worked on a variety of high-profile government projects, including the construction of underground bunkers and secure facilities. Jonathan Reed, a senior engineer at the company, was chosen to lead the project. Reed was known for his meticulous attention to detail, his ability to manage complex projects, and his experience with high-security environments. For Reed, the underground expansion represented the pinnacle of his career, a chance to apply his skills to a project of unprecedented scale and importance. From the outset, Reed understood that this project would be unlike any he had undertaken before. The level of secrecy required was extraordinary, even by the standards of Area 51. All aspects of the project, from the initial planning stages to the final construction, were classified at the highest levels. Reed and his team were required to undergo extensive background checks and security clearances, a process that was both exhaustive and invasive. The clearance process for Reed was particularly rigorous. Before he could even begin working on the project, He was subjected to a series of interviews, psychological evaluations, and polygraph tests, all designed to assess his loyalty, stability, and trustworthiness. His financial records were scrutinized, his personal life was investigated, and his communications were monitored. The goal was to ensure that Reed posed no security risk and that he could be trusted with the immense responsibility of overseeing such a sensitive project. Once cleared, Reed was granted access to the project's details, which were stored in a secure government facility. The information was only accessible within a specially designed room, shielded from electronic surveillance, and Reed was required to sign an ironclad non-disclosure agreement. Any breach of this agreement would carry severe consequences, including potential legal action and the loss of his security clearance. With security measures in place, Reed and his team began the detailed planning phase of the expansion project. The first step was to conduct a comprehensive geological survey of the site to determine the best locations for the new levels. The survey revealed a mix of challenges, including the presence of fault lines, varying rock compositions, and areas of potential water intrusion. These factors had to be carefully considered to ensure the stability and safety of the underground structures. The planning phase also involved the design of the new levels, each of which required customized solutions to meet its specific requirements. For example, Level B2's laboratories needed to be isolated from vibrations and electromagnetic interference, necessitating the use of special construction materials and techniques. Similarly, the command center on Level B4 required hardened communication lines that could operate independently of the surface infrastructure, ensuring continuous operation even in the event of an emergency. Reed and his team also had to consider the logistics of construction in such a remote and secure location. The transportation of materials and equipment to Groom Lake was tightly controlled, with all shipments subject to inspection and approval by security personnel. Construction crews were working in shifts to ensure continuous progress while maintaining strict adherence to security protocols. The expansion project officially commenced in the early spring of 1992, marking the beginning of a complex and tightly controlled operation at the highly classified Groom Lake facility. The first phase of the expansion involved a series of carefully orchestrated activities designed to prepare the site for the massive underground construction that would follow. This phase was as much about logistics and coordination as it was about engineering, requiring meticulous planning and execution. The first task was to establish a secure perimeter around the designated expansion site. This area, located several hundred feet from the existing underground structures, had been chosen for its relative geological stability and distance from known fault lines. The perimeter was marked out with military precision, using advanced surveying equipment to ensure accuracy. Security was paramount. Armed guards patrolled the perimeter, and surveillance cameras were installed to monitor all activity within the construction zone. Access to the site was tightly controlled, with multiple checkpoints and identification protocols in place. Only personnel with the highest security clearances were allowed within the perimeter, and all movements were logged and monitored. One of the most unique aspects of the project was the daily commute for construction workers involved in the project. Unlike typical job sites, where workers might drive to a location or stay in nearby accommodations, the workers at Groom Lake were flown in every day from Las Vegas on a highly classified airline known as Janet. Janet, an acronym that has been speculated to stand for just another non-existent terminal, was the unofficial name for a fleet of aircraft operated by the U.S. government to shuttle employees and contractors to and from highly secure locations, including Area 51. The planes were based out of a private terminal at McCarran International Airport in Las Vegas, easily recognizable by their unmarked white fuselages and a single red stripe running along the side. Although the airline's existence was known to some in aviation circles, the details of its operations were, and still are, shrouded in secrecy. Every morning, before dawn, construction workers would gather at this terminal, passing through a rigorous security screening process before boarding the Janet flights. The atmosphere in the terminal was one of routine mixed with an underlying sense of mystery. The workers had signed non-disclosure agreements and knew better than to ask too many questions about their destination or the purpose of the work they were doing. For them, it was simply a well-paying job, and they focused on the task at hand. The flights themselves were short, typically lasting around 45 minutes, but the journey was not without its procedures. As the planes approached the restricted airspace surrounding Groom Lake, the pilots would radio in special clearance codes. Upon receiving permission to enter, the planes would descend towards the base, landing on a runway that was off-limits to all but the most authorized personnel. From there, buses would transport the workers directly to the construction site, minimizing exposure to other areas of the base. The daily routine was as precise as the construction process itself. Workers would arrive on site early in the morning and begin their shifts immediately. At the end of the day, they would be transported back to the runway, board the Janet flights, and return to Las Vegas, where they would disperse back into civilian life. This cycle repeated itself day after day, with little variation, ensuring that the project moved forward without delay. With the perimeter secured and the workforce in place, the next step was to clear the surface area and begin the excavation process. Heavy machinery was flown in under the cover of darkness and assembled on site. These included massive earth movers, drilling rigs, and specialized tunneling machines designed for deep underground construction. Each piece of equipment had been specially modified to operate in the harsh desert environment and under the stringent security conditions of the project. The surface area was cleared of any vegetation and debris, and the topsoil was carefully removed and stored for later use in camouflaging the site. The team then began the process of drilling down to create the initial shafts that would eventually connect the surface to the new underground levels. These shafts were designed to be the main access points for materials, equipment, and personnel during the construction phase. Excavation was a slow and deliberate process. The team encountered several layers of rock, each requiring different techniques to break through. The upper layers, composed of loose sediment and sand, were relatively easy to remove, but as the drilling progressed deeper, the rock became harder and more challenging to penetrate. This required the use of advanced drilling technology, including diamond-tipped drill bits and high-pressure water jets to cut through the toughest sections. One of the early challenges encountered during the first phase was the discovery of unexpected geological formations. As the team drilled deeper, they came across pockets of unstable rock and small caverns filled with groundwater. These formations posed a significant risk to the stability of the planned underground structures and required immediate attention. Jonathan Reed, ever the problem solver, called in a team of geologists to assess the situation. After extensive analysis, it was determined that the unstable areas could be stabilized using a combination of techniques. The first step involved injecting a specially formulated grout into the rock to fill any voids and reinforce the surrounding structure. This was followed by the installation of steel reinforcements and concrete linings in the affected areas, ensuring that the shafts would remain stable throughout the construction process. The discovery of groundwater also necessitated the design and installation of an advanced drainage system. This system, integrated into the shafts and tunnels, was designed to capture and redirect any water that might seep into the construction zone. The drainage system was connected to a series of pumps that would remove the water and channel it to a secure holding area away from the construction site. These geological challenges, while unforeseen, were not insurmountable. Reed's ability to quickly adapt and implement solutions ensured that the project remained on schedule, despite the setbacks. Once the ground was cleared and the geological issues addressed, the team began the construction of the main access shafts. These shafts, each several hundred feet deep, were designed to be the primary conduits for moving materials, equipment, and personnel between the surface and the new underground levels. The shafts were reinforced with a combination of steel and concrete, creating a stable and secure structure that would support the weight of the surrounding rock. As each shaft was completed, it was fitted with a custom-designed elevator system capable of transporting heavy loads. These elevators were not only robust but also equipped with advanced safety features, including redundant power systems and emergency braking mechanisms. In parallel with the shaft construction, the team also began digging the horizontal tunnels that would connect the various underground levels. These tunnels were designed to be wide enough to accommodate large vehicles and equipment, allowing for the efficient movement of materials throughout the site. The walls of the tunnels were reinforced with steel girders and lined with concrete, providing both structural integrity and protection against potential cave-ins. One of the key challenges in tunnel construction was maintaining proper ventilation. As the tunnels extended deeper into the earth, the air quality began to deteriorate due to the presence of dust, fumes from machinery, and the natural accumulation of gases. To address this, Reed's team installed a series of high-capacity ventilation systems, including air intakes and exhausts strategically placed throughout the tunnels. These systems were designed to maintain a constant flow of fresh air, ensuring a safe working environment for the construction crews. The first phase of the expansion also involved the installation of essential infrastructure, including power and communication systems. Given the remote location of Groom Lake, the team needed to ensure that the underground expansion would have a reliable and secure supply of electricity. This was achieved by extending the existing power grid from the surface installations down into the new underground levels. High-voltage cables were carefully routed through the shafts and tunnels, protected by layers of insulation and shielding to prevent damage from moisture or rock movement. Backup generators were installed at key points within the underground complex, providing an additional layer of redundancy in case of a power failure. These generators were connected to large fuel reserves, capable of sustaining operations for extended periods if necessary. By the early fall of 1994, the expansion project had reached its final structural milestone. Jonathan Reed and his team had spent the better part of 2 years excavating, reinforcing, and constructing the complex network of underground tunnels and chambers deep beneath the desert floor of Groom Lake. The time had come to hand over the project to the next team of specialized contractors, who would be responsible for installing the advanced systems and technologies that would bring the new underground levels to life. The final weeks of construction were a flurry of activity as the team worked to complete the remaining tasks and ensure that every aspect of the structure met the rigorous standards required for such a high-stakes project. The main tunnels and chambers had been fully excavated and reinforced, and the access shafts were equipped with high-capacity elevators capable of transporting personnel and heavy equipment between the surface and the subterranean levels. Reed conducted multiple walkthroughs of the entire complex, accompanied by his key engineers and foremen. These inspections were thorough, with every inch of the tunnels and chambers scrutinized for potential issues. The team checked the integrity of the concrete linings, the stability of the steel reinforcements, and the functionality of the ventilation systems that had been installed to maintain air quality deep below ground. Any minor defects or imperfections were quickly addressed, ensuring that the facility was handed over in pristine condition. One of the last major tasks involved the installation of temporary lighting and power systems throughout the underground levels. These systems were essential for the incoming contractor teams, providing them with the necessary infrastructure to begin their work immediately upon arrival. Although these systems were temporary, they were installed with the same attention to detail and security as the rest of the project, ensuring that they would function reliably until the permanent systems were in place. As the final inspections wrapped up, Reed felt a sense of accomplishment mixed with a touch of relief. The project had been fraught with challenges, from geological surprises to the logistical complexities of working in one of the most secretive locations on Earth. Yet, through it all, his team had persevered, delivering a state-of-the-art underground facility that would serve as the foundation for whatever classified operations were to come. With the structural work complete, the next phase of the project began. A new set of contractors, highly specialized in the installation of advanced systems and technologies, arrived at Groom Lake. These teams were responsible for outfitting the underground levels with the sophisticated equipment and infrastructure needed to support the facility's top-secret functions. The transition between Reed's construction team and the system's installation teams was a carefully managed process. Security protocols required that the two groups have minimal direct interaction to maintain the compartmentalization of information, a key principle in the world of classified government projects. As such, the handover was conducted in stages, with Reed's team gradually withdrawing from the site as the new contractors moved in. The system's installation teams were composed of experts in various fields, including electrical engineering, computer systems, environmental control, and advanced security technologies. Their work would involve installing everything from power grids and climate control systems to data networks and surveillance equipment. Each system was critical to the facility's operation and had to be integrated seamlessly into the complex structure that Reed's team had built. One of the first systems to be installed was the permanent power infrastructure. This included a series of massive generators, designed to provide a stable and secure power supply even in the event of external disruptions. These generators were connected to a network of distribution panels and transformers, ensuring that electricity could be delivered to every corner of the underground facility. Alongside the power systems, the teams also began installing advanced climate control technology. The depth of the underground levels meant that natural ventilation was insufficient, so a sophisticated system of air conditioning units, dehumidifiers, and air purifiers was necessary to maintain a stable and habitable environment. These systems were designed to operate autonomously, with built-in redundancy to prevent any single point of failure from compromising the facility's operations. The handover process itself was conducted with the same level of secrecy and precision that had characterized the entire project. Reed's team compiled extensive documentation detailing the construction process, the materials used, and the as-built specifications of the underground structure. This information was vital for the incoming teams, who needed to understand every aspect of the facility to properly install their systems. The documentation was handed over in a series of secure briefings, attended only by the highest-level personnel from both Reed's team and the incoming contractors. During these briefings, Reed provided insights into the challenges his team had encountered and how they had been overcome, offering valuable knowledge that could aid the new teams as they undertook their work. Once the handover was complete, Reed's team began the process of demobilizing from the site. Equipment was carefully dismantled and transported back to the surface, where it was loaded onto the same unmarked aircraft that had brought it to Groom Lake. Temporary structures, such as site offices and storage facilities, were disassembled, leaving little trace of the extensive construction operation that had taken place. As a final step, the access points to the underground levels were secured. Heavy steel doors, installed at the entrances to the main shafts and tunnels, were locked and sealed. These doors were designed to be virtually impenetrable, ensuring that only authorized personnel with the correct clearance could enter the newly constructed facility. For Reed, closing these doors marked the official end of his involvement in the project, a moment that was both satisfying and bittersweet. On the final day of their involvement at Groom Lake, Jonathan Reed and his remaining crew members boarded a Janet flight back to Las Vegas, just as they had done so many times before. This time, however, there was a palpable sense of finality in the air. The project that had consumed their lives for the past 2 years was now complete, and they were leaving behind a structure that few would ever know existed. As the plane ascended over the Nevada desert, Reed allowed himself a moment of reflection. The challenges had been immense, the stakes high, but the team had delivered on every front. They had expanded Groom Lake's underground infrastructure, creating a complex that would undoubtedly play a crucial role in whatever secretive operations the government had planned. For Reed, the project was more than just a job. It was a testament to what could be achieved when precision engineering met unyielding determination. While the specifics of the facility's future use remained a mystery to him, he took pride in knowing that his work had contributed to something larger, something that would endure long after his team had departed. As the Janet flight touched down in Las Vegas, the crew disembarked quietly, blending back into civilian life as if they had never been part of one of the most classified construction projects in history. The Black Echo expansion was now in the hands of others, who would complete the task of transforming the underground structure into a fully operational facility. Reed knew that he might never return to Groom Lake, but the mark he and his team had left on the desert beneath the Nevada sands would remain, hidden but indelible.